3D physics is finally here in GDevelop, and in this video I'm going to be showing you how to make a 3D physics platformer in GDevelop. Let's get right into it. So let's get started making this 3D physics platformer in GDevelop because GDevelop 3D is so back right now. There's so much to do with this. Of course, we know for a platformer game, we need a player and we need ground, because what we're going to be doing in this part, we're going to create a player that can move around. We'll have a third-person camera, and we'll also be able to dash and double jump. We're doing all of that in this first part with 3D physics. So let's add new objects, and of course we want to add a 3D box. You could use a 3D model, but for now we're going to be using a 3D box. This will be changed later when we start animating though. We're going to name this as player. Now, when it comes to all the faces of the player cube, we want to make sure we check on all of the faces so that they can be seen, and we also want to create a file with Piskel. So we're going to use Piskel, and what you can do is just click one of the colors that you have, and you can just use the paint bucket tool and just color the whole thing anything you want. I'm going to make this player actually blue, and we're going to save it. And you don't have to do this individually for all of them, because now when you click the empty box for the face, you'll already have the file that pops up. So we'll have 3D box 2, and we're going to fill this in for all the faces. So if I'm going to hit apply, and we drag it onto the scene, and when we preview, of course we see that nothing happens, because right now we just have a static 3D cube that doesn't move. So let's actually add a behavior to it. Now if I double click and then go into behaviors, you may remember that we don't really have any behaviors besides the old 3D jump for a 3D platform, but that's actually false because GDevelop added new behaviors for 3D physics. So let's add a behavior, and let's type in 3D physics character. 3D physics character. And you'll see that we have down here 3D physics character, and this is specifically for 3D platformer games. Do not just add this to any 3D object. This is specifically for 3D platformer games. And you'll also see that we have something similar called 3D physics engine, and we're going to look into that a little bit further. But let's click into 3D physics character first. Now, if you scroll up, actually, you'll see that we have two behaviors that just got added. We have the physics 3D behavior, and we also have the physics character 3D behavior. And now the physics character 3D is just like a regular platformer behavior. You'll see we have maximum falling speed, we have the gravity, we have the jump height. We can change all of that. We can change all of that using this behavior. But also we have the 3D physics behavior. And this is because we're a 3D physics object as well. This is a mixture of two behaviors. And what we do want to change some things here, because we're going to be moving around our player. But normally for a player, especially for the type of game we're trying to make, we want a regular character, not one that's moving around all the time. And you'll see that for the type of physics object we have three types. We have dynamic, we have static, and we have kinematic. Now dynamic object, they always move around, just like an object in real life. If you apply a force to them, they'll move around. If you throw them up in the air, it'll automatically move and fall back to the ground because of gravity. That's how dynamic objects work. Static objects, they never move, ever. Even if you try to use events or behaviors to move them, static objects will always stay in place. And you can look at them at the ground in real life. Of course, the ground technically can move, but it's so heavy that it's basically static, that you won't be able to move it. And then we have kinematic. And kinematic is a mixture of dynamic and static, because normally kinematic objects don't move, but if you apply a force on them using behaviors or using certain events in the event editor, then they will move. And that's why we want kinematic, because normally we don't want to be moving unless it's getting moved by our behavior down here. This behavior will still make us move. So even though we're kinematic, we're still going to be moving. And fixed rotation, we also want to set that on, because we don't want our player to just be moving very wildly. And the 3D physics behavior character will automatically cover certain rotations for us. Now, we also have an option, keep object angle forward and forward direction the same. We're going to keep this the same. We're going to keep the object angle and forward direction the same. And forward direction is just how we move forward. So if our object is facing a certain way, whichever way it's facing, it will automatically move forward in that direction. So we're going to keep that checked on as well. Now let's hit apply, and if we preview, we still won't be able to move yet. We can try to use the arrow keys to move, but we know that it's actually working because now the player object is falling. Now, in order for it to stop falling, of course we know we're going to need some ground. So let's add a new object, and let's create another type of 3D box, and let's rename this 3D box to be ground. Now, we want to make sure we check on all of the faces, and let's create another cube with Piscal. And let's make this a different color, and let's create the ground as, we're just going to create it as green. So I'm going to use the paint bucket, we're going to make it green, and then save it. You'll see that this is the name, so when you go into the blank bar, make sure you match the same name for all of the faces. We're going to quickly do this, and we're going to fill that in. Now, another thing that we need to do is add the 3D physics behavior to it. And that's because if you have a 3D physics object, it will go through any object that's not a physics object, a 3D physics object. So whenever we're dealing with these two, if we want to collide with something, it has to also be a 3D physics object. It can't be a regular 3D object. So let's add a behavior to the ground. And we already have the 3D physics engine. We can click that in here. And you'll see that's also called physics 3D. And remember, the ground doesn't move. So that means we want there to be a static type of object. The ground will never move. So we're going to make it as static. And we're going to hit apply. Now I'm going to drag the ground onto the scene. And one thing that we want to do is that we want to make the player spawn higher than the ground. Now when it comes to 3D, if I preview, you see that we're looking at the game from a top-down view. And if I click into the player and we look at the position of the player, we have the X, we have the Y, we have the Z. If I move X, you see that I move to the right and left. If I use the Y, you see that I move up and down, but only in a top-down view. I'm moving up and down. And if I change the Z to something higher or lower, you'll see that I'm moving up and down. Or in our case, it's moving closer to us. But when it comes to the game, a 3D game in GDevelop, if you want to make the player higher, you need to change the Z position. So we're going to change the starting Z position of the player to be 300, and we're going to keep it like that. And we're going to drag the ground under the player and completely drag it out so that the player has something to stand on. And now that we have this, we're going to preview. And if I preview now, you'll see that we completely just land on the ground without falling infinitely. We land on the ground without falling to our death infinitely. So now that we have that, we have another issue. Our player can't move right now. Our player cannot move at all. So how do we fix the player not being able to move? Well, let's X out of here, and we're going to fix the player not being able to move. Now, you probably may think, and this is what a normal person would think. They'll think that, of course, we have to just use some events to make the player move. Completely wrong. GDevelop has extensions for almost everything. So let's go into the behaviors for our player, and let's add a new behavior. Now, we're going to add a behavior called 3D Keyboard Mapper. 3D Platformer Keyboard Mapper. So we're going to click into it, and if we scroll it down, you see that we have it already mapped out for our movement. We have the 3D platform mapped out in movement. Our up key is W, our down key is S, and W is actually forward. Jump key is space, left key is A, right key is D. Now, the good thing about this behavior is that you can edit it. If you want to move with the arrow keys, you could just change this to up instead. But in our case, we're going to just leave it with W as up. We're not going to change anything here right now. So let's hit apply and let's preview. Now, let's see what happens. If I press W, you see that I'm moving upwards. If I press S, I'm moving backwards. So press D, moving to the side, press A. If I press space, you see that I'm jumping up. So everything is working. Now we can actually move. And you see that we're also rotating. If I use the diagonals, and this is because this is how the 3D physics character, platformer character behavior works. We're moving around like an actual platformer character. So this is very, very good right now. So let's just X out of here. And now that we have the movement done, we need a much better camera angle. We need a much, much better camera angle. So let's double click into our player and go into behaviors. And you already know we're about to add a behavior for the camera. Let's add a behavior, and let's go find the third person camera, because third person means we're looking outside the player. We're not inside the player looking like it's their point of view. We're looking at the player from a distance. So let's click into the third person camera. You'll see that we have an option automatically rotate the camera with the object. We're going to actually uncheck that here. And if it leads to a problem later, we'll just check it back on. But we have automatically rotate the camera with the object. And we're not going to do that one. Well, actually, let's check it on, and then we'll just turn it off if something goes wrong. We have a bunch of different settings, but the most important ones right now for this tutorial are camera distance and the elevation angle offset. And this basically changes the angle in which you're above it. And the camera distance is self-explanatory. It changes how far away the camera is from the player. And we have some advanced properties as well. Like I said, not very useful unless we're going into a deep dive of the third-person camera. So let's hit apply, and let's preview this now. And you'll see that now this view looks way different. This view looks way different. But you see that one thing that's a little bit annoying is that every time we even move a little bit, you see that the camera just keeps rotating. It keeps rotating. So let's uncheck that option. Let's double click into our player, go into behaviors, let's scroll down to the third person camera, and we don't want to automatically rotate the camera with the object, because that's very annoying. We can't even tell what's really happening. So this is much better. Now we can actually see the player without the camera just always constantly moving like crazy. But we still have a problem with the camera that can't be solved by extensions or behaviors. We have a problem in that the camera is still way too inflexible. What if I want to look to the left or look around me or look above me? You can't do that. And that's not normal for 3D platformer games. So we need to change that. We need to change that. Now, in order for us to change that, we're going to add a hybrid. And what I mean by a hybrid of cameras, we're going to have to add a mixture of a third-person camera, which we already have, but we're also going to have to add some first-person camera elements, and which means we're going to be able to move the camera with the mouse as well. We're going to have to move the camera with the mouse. Now, if you're familiar with making 3D games in GDevelop, you know that we're going to need the mouse pointer lock extension. But if you're not familiar, we're going to need the mouse pointer lock extension anyway. So I just said the same thing. But what I mean by that is that the mouse pointer lock extension, it locks the mouse into the game. And what I mean by this is if I click right now, you'll see that you can see the mouse cursor. But if I move around, you see that the mouse is actually going out of the game screen. If I go full screen, it's still the same thing. We're reaching the edge of the box, which will limit our camera movement. So we need an extension that will lock the mouse into the game. So let's go into our project manager in the top left, and let's add a new extension. Let's click to add extension, and let's type in mouse pointer lock. And you'll see that we have mouse pointer lock made by the one and only Pandako. Let's install this into the project. Make sure you're connected to the internet or it will not work. And let's close this out. Now let's finally go to our events instead of using behaviors for everything. Let's go into our events. And now we need to, first of all, make some conditions for locking the camera. Well, locking the mouse. Now, when we click into the game, we want to lock the mouse. That's basically the main one. When we click into the game, we want to lock the mouse cursor. But also, we want to make sure that the mouse pointer is not already locked. Because, of course, we don't want to repeat the event if the mouse cursor is already locked. So basically what we're saying is that if the mouse cursor is not locked, and if the mouse button is pressed down, the left mouse button is pressed down, then we want to lock the cursor. So I'm going to say this again. Let's add condition, and let's do this in real time. Let's go into other conditions, and we want to go into mouse pointer lock. And if the mouse pointer is not locked, because we want to invert the condition, because this one's saying if it is locked, so we want to inverse it. So now we're saying if the mouse pointer is not locked, and we want to add another condition, let's go into other conditions. Let's go into our mouse and touch, and we want to see if the mouse button is pressed. If the mouse button is pressed. So, we want to see if the left key is pressed. Let's click OK. Now we have the condition. If the mouse pointer is not locked, and if the touch or left mouse button is pressed down, then we want to do a certain thing. And remember, the thing that we want to do is lock the mouse cursor. So let's click into mouse pointer lock, and let's request the pointer lock. And this will lock the mouse pointer like it says here, and it will hide it. So let's click OK. And if we preview now, if I click into the game, you see that the mouse cursor disappears. Now, of course, we can't move around right now because we haven't made any events to do that. But how do you actually escape from this? Well, to escape from this, no pun intended, all you have to do is press escape on your keyboard.
Oh my god! Wow!
And your mouse will automatically reappear. Click back into it, it's gone, press escape, it will reappear. So now that we have that, we have the mouse pointer locked in. Now we need to actually make the camera able to move around. Let's make the camera able to move around. So, We're going to need one condition for this, and we want to check if the mouse pointer is locked. We don't want to move the camera if the mouse pointer is not locked. So let's add a condition, and let's go into other conditions. Let's go into mouse pointer lock, and let's make sure that the pointer is locked. That's the only condition we need for this one right now. Now, for moving around the camera, we want to change the rotation of the player. We're going to be changing the rotation of our player. So let's go and add an action, and let's click into our player, and let's type in rotation, the camera rotation of our player. And basically, we're changing the camera rotation of the third person camera. That's what we're actually doing. But we have to click into our player first because the third person camera behavior is attached to our player. So we want to change the camera rotation, and we're going to set it, we're going to add something. Now, this is going to be a little bit complicated. I'm going to explain it after the fact. So we're going to put 120 times mouse pointer lock movement X. And we're going to put parentheses. And I forgot one thing, mouse pointer lock movement, mouse pointer lock. And this is a little bit complicated. That's why I'm explaining it after. And then we're going to put divided by scene. And this is actually not necessary, this part. But scene window width. And shout out to GDevelop because I'm using some of their camera events because they just work really well and are extremely flexible. Now, what are we even doing here? Because I like to explain what's going on. We're adding a value to the camera rotation. We're not saying it equal to something because mouse pointer lock movement X. We're getting the movement. We're adding the movement of the mouse cursor. That's basically what we're doing. We're adding the movement of the mouse cursor to the camera. Now, we're multiplying it by this value because it's going to be a really small number if we don't multiply it by 120, which is, you don't have to have this value. This will just change how fast it moves. But we're dividing by the scene window width. And like I said, this is some of GDevelop's events. But what it does, this makes it flexible and it'll still work right no matter what your scene window width is. So that's why this part is added right here. And that's why the 120 is used. But actually the most important part right here is mouse pointer lock movement X. Because what we're doing is basically adding the movement of the mouse cursor. So when you're looking at all this complicated stuff here, all you need to know is that what we're doing right now is we're adding the movement of the mouse cursor to the camera. So that's what we're doing here. So also what we want to do is change the elevation offset, which is like the upwards view. Because right now this is controlling the camera horizontally, but we also want to be able to control the camera vertically. So we're going to add some events for that, or an action for that. So let's add an action, let's click into our player, and we want to change the elevation angle offset of the player. So we're going to also add this value, and I'm going to put mouse pointer lock movement Y. And I'm not sure why it's not auto-completing, because normally it auto-completes it in GDevelop, but it's not for some reason. So we're going to put mouse pointer lock movement Y, and then put parentheses. We're also going to put 120 at the start, use the multiplication symbol. And we're also going to divide it by, instead of scene window width, since this is vertically, we're going to put divided by, which we're going to put / scene window height. So this will make it flexible no matter what size your screen is. That's all that this is doing right now. Now if I preview, let's see what happens, because this might be very weird. If I click into the game and then move around, you see that I can move around for a little bit, but then you see that the camera will snap back. The camera will snap back, and we can also flip all the way around. Like, we can do crazy types of camera movement, even look upside down. So those are two problems we have right now. So we're going to use a technique that we like to call halftime rotation. Now, once again, shout out to GDevelop because they made the extensions for this, so they know exactly how to use it. But halftime rotation stops this snapping that we're dealing with right now. It stops the snapback and allows us to just move freely. So we would need to add some halftime rotation for if the mouse is moving. So how do we do this? We're going to create a sub event. I know this is kind of complicated. We're getting a little bit advanced, but we're going to put Shift D to make a sub event, or you can just right click and add, and then add a new sub event. And the condition that we want to see if the mouse is moving, because we're trying to prevent that snapback. So we're going to add a condition, click into our player, and then we're going to type in, is the mouse moving? We want to see if the mouse pointer lock is moving. And this is the wrong place to do it. Let me go into mouse pointer lock. If the pointer, if it's locked and if it's moving. So if the locked pointer is moving, then we want to activate halftime rotation. So we want to change the halftime rotation for our player. We're going to click and we're going to type in half. And you'll see that we have halftime for rotation. And this will stop the snapback. This will stop the snapback of the player. So we're going to set this value equal to something super high. Let's set it to like 1 million. 1, 2, 3, 4, 5, 6. 1 million. And we're going to hit OK. So if I preview this now, let's see what happens. You see that we click and I can move around and the camera won't snap back. It actually stays where it usually was. Now, if you want the camera to snap back, that's completely fine. But normally, in most games, you'll never want the camera to snap back like that. So we're just going to keep everything. We're going to keep everything the same right now. So this is all good. This is all good. But we do need to stop this issue of us being able to just turn around however we want. And we can literally look upside down. So we need to limit the mouse movement or limit the camera movement for our player and for our game. So how do we limit? Well, we have to use what's called clamping. And what clamping is that you're limiting a value. The value is still allowed to move, but it has a minimum value that it can be at, and it also has a maximum value it can be at. So let's add a new event. And for this condition, we want this to have no condition because we always want the camera to be locked down. Now, how do we lock down the camera? Well, remember, this camera is being based off of our player's movement in a way, especially the Y position of the camera. So we want to limit the Y rotation of the player. Because the player's Y rotation is limited, that means the camera's Y rotation will also be limited. So let's go add an action and let's click into a player. Let's type in rotation and on the Y axis. Rotation on the Y axis. And we want to set this equal to, whenever you're clamping, set it equal to. Now, the first thing when we're using the clamp function, we want to type in clamp first and then put in parentheses. And you'll see that we have 3 parameters. We have the first number, which is the value that we're trying to limit. Then we have the minimum and we have the maximum values. So let's type in the parentheses and let's go inside of them. So the first value is the value that we want to limit. And remember, we want to limit the player's Y rotation. So what we're going to do is type in player dot rotation. And then we have rotation Y. But you actually don't have to put in the really long version. All you have to do is put player dot rotation Y, and then put parentheses. Now, after you're done with that, we're going to put a comma, and then we have the maximum value. Well, we have the minimum value. The minimum we're going to set to is -90, and basically that's just the bottom. That's just the bottom. You can't see past your own feet. Think of it like you're like a human head. You can't stretch too far back, and you can't stretch too far down. So let's add another comma, and we have the maximum value now. The maximum value will be 90. Positive 90. So let's go click and let's see if everything works correctly. For the Y value anyway, this limits the Y rotation. Let's go and look up. You see that we still have an issue of looking upside down. Now the player don't have an issue, but the camera elevation still has an issue of being able to look up and down. We will also want to limit the elevation angle offset. So let's add an action and let's click into our player and let's type in elevation angle offset. And we also want to clamp this. So we're going to set equal to. We're going to type clamp first. And the thing that we want to limit, we're going to put player. So we're trying to limit the third person. We're trying to limit the elevation angle offset, which is responsible for our Y rotation. Let's type in player first. And we're trying to access something on the third person camera behavior. So we're going to type in third person camera. Let's use tab to autocomplete it. And then we're going to put in elevation angle offset, tab to autocomplete it. That's why it's going so fast. We're going to put comma because that's the value we're trying to limit. And now we're going to put, once again, -90 at the minimum, comma, and then 90 at the maximum. So now we're limiting the player's Y rotation and we're limiting the elevation angle, which is basically almost the same thing in this case. We're limiting both of them to be the same values. So they can't go too high and they can't go too far down. So we're going to click, and now if I try to look all the way up, you see that I can't. If I try to look all the way down, see that I can't. Now it can go a little bit farther, guys, because the ground's so skinny, but there's still a limit to it. I'm trying to keep going down. it will never loop all the way up because it's limited. Remember, if you want to limit it even more, you can just change these minimum and maximum values. And now that you've done that, we're almost at the final stretch. You've gotten done with the most complicated part. But we're still not done yet. We have a decent amount of things we have to do. We're going to add a double jump, and we're also going to add a dash. We're doing a bunch with the 3D physics because there's so much you can do, and so much we haven't even covered yet. So let's go into our untitled scene, and let's double click into our player. Now the double jump is easy because, once again, you should already know by now, GDevelop has a behavior for 3D double jumps. So let's go into behaviors, and let's add a behavior. And we're going to type in advanced. Let me delete everything first. We're going to type in advanced jump for 3D. Do not put coyote time and air jump for regular because that's for 2D. This is for 3D. Make sure you put for 3D. And if we click into it, you'll see that we have two things. We have air jumps, which are the same as double jumps. And then we have coyote time. And you already know what a double jump is. But what coyote time is that it gives you a little bit of leeway after falling off a platformer. Well, falling off a platform. Most games have this feature where if you fall off the platform, you have a little bit of time and you don't even notice it because the time is so low, like this, 0.25 seconds. You don't notice that you fell off the platform, but you give them a little bit of leeway. So even if they just slipped off the platform, if they were to press the jump button, they'll still have a jump. So it's giving the player a little bit of leeway. And this is in most modern platformers, but you don't even notice it. We're going to keep the coyote time on, but if you're really like old school, you can set the coyote time to 0, and that'll give them no leeway at all. But we're going to put 0.25, and number of air jumps, we're going to keep it at 1, so we can double jump. So we're going to hit apply and preview. So if I press space and then press it again, I can double jump. And remember, you can add more air jumps, or you can have 0 air jumps. So now we have a working camera. We can jump, and we can even double jump. So we're going to get out of here. And one thing we're going to do, one last thing, this is completely extra, but I just had to do it. We're going to add a dash because many platformers you can dash. Not all of them, but dashing is a very cool feature to have in your platformer. Now, what you'll think we're going to do is that we're just going to add a force to the player. Now, normally this would work for physics objects, and you think it should work. But for our 3D physics character behavior, you can't simply just add forces to your object. That is one downside to this platformer behavior. The physics character 3D behavior, you cannot add forces to your object. It won't work. It simply will not work. If I try to add force to the object, no matter if it's kinematic, dynamic, or static, it will ignore it because of this extension. This extension will ignore events, forces from my testing. So we have to have a workaround. And what we're going to do is we're going to change the forward speed of the player when we dash. That's exactly what we're going to do. So let's go into our events and let's add the dashing behaviors, well, the dashing events for our player. So let's go and add a new event. Now, of course, we need a condition. And basically, if a certain key is pressed, then we want to dash. Now, the key that we're going to have pressed, I'm going to put, for the dash key, I'm going to put Z. Let's add a condition. Let's go into other conditions. Let's go into keyboard, and let's go into key press. Then we're going to go and click Z. We're going to go and type in Z, not click Z. And then we're going to hit OK. Now, we have the condition set up. So now we want to change the forward speed of our player. It's just going to change our forward speed. So let's add an action. Let's click into our player. And let's type in forward speed. Type in forward speed of current forward speed. Make sure it's current forward speed and not max speed. Because basically, no matter what speed we're at, it's automatically going to change our current speed to this value. So we're going to set it to, I'm going to put 2000. You can set it to whatever value you want. And now we have a dash. Now we're not done yet. We're going to have an issue. You know we always have an issue. We're not going to be done that fast. But before we test it out, I'm going to add some more space for the player. Since we're going to be dashing around, we need some more space. So I'm going to stretch out the ground. And we're going to preview this. Now, we can jump around. We can move around. That's all cool. Everything's fine. But let's press Z. And I'm pressing W first so you know that I'm facing forward. It's hard to tell because we're using a cube where all the sides are the same, but I'm facing forward right now. If I press Z, you see that I just dash forward. I just boost it forward. And to make it more obvious, since I'm near edge now, I'm going to jump in the air, press Z, I dash forward. But a problem that you don't know right now, let's preview this and do this again. What if I just keep pressing Z? You see that I'm forever in a dash state. And you know 99% of games with a dash have a cooldown because we don't want the player just flying around the place all the time. So we're going to set up a cooldown for our player. Now this is not going to be complicated. This is going to be extremely easy actually. This is going to be very, very easy. So we're going to, what we need is basically a Boolean variable called can dash. And this will check whether or not the player can dash. And when the player dashes, it'll set the variable to false. Then it'll wait 2 seconds, or whatever seconds you want. It'll wait a certain amount of time, and it'll set it back to true, and you'll be able to dash again. So first, we need to double click into our player and create a variable. We're going to call this variable can dash. And this is going to be a Boolean variable, which means it only has 2 values, either true or false. And by default, we want to set this to true, since by default, we want to be able to dash. So let's hit apply, and let's go into our scene, or our scene events. And you see that for our condition here, we need to add a few things. If the Z key is pressed, and if can dash is true, and if can dash is true. So let's go and add a condition. Let's go into other conditions, events and control flow, and then and. And we want to check if can dash is true. Let's add a condition. Let's click into our player, and let's type in variable, because we're trying to access a variable on our player, variable value, and we want to check if can dash is equal to true. And one thing we're also going to do is set this to trigger once. You don't have to do this, but if you don't want your player to be able to hold Z to keep dashing automatically when the cooldown ends, you want to set this to trigger once. But if you do want them to be able to hold it and automatically dash as soon as it's refilled, then you can leave it like regular. But for me, I don't like that, so I'm going to add a condition, other conditions, and then set this to trigger once. So now that we have that, remember what we're going to do. Right after we dash, we want to set can dash equal to false, so we can't do it again. So let's add an action. Let's click into our player, and let's type in variable, because we're trying to change can dash being equal to false. And remember, now we need the cooldown, because what's happening is that if the Z key is pressed and can dash is true, what it's going to do is make us dash by changing the current forward speed, and then what it's going to do is set can dash equal to false. But if we leave it at that, it will stay at that forever and we'll never be able to dash again. So now we need to wait a certain amount of seconds and then set can dash back to true. So let's add an action and let's wait a certain amount of seconds. So let's go into other actions, timers and time, and then wait X seconds. I'm going to wait 2 seconds before we can dash again. So if I hit OK, now we're waiting 2 seconds, and the last thing that we need to do is set can dash as being equal to true. Now I'm going to actually click can dash, this one right here, this action, right click it, copy it, scroll over add action, and then paste it. So I'm going to double click, and then we're going to set this to being equal to true. So now if I preview this, I'm going to show you that we can't just spam dash anymore. So I'm actually going to look over here, just so you can know. I'm going to walk over here, then face forward, and I'm going to just click right here. I'm going to press dash once, and that's not a good example. Let me just preview again like this. I'm going to keep pressing Z. I'm spamming Z right now. You see I'm at the edge, I'm still spamming Z. And then I can dash again after the 2 seconds. So that's how you set the cooldown for your dash. And with that, we've actually completed the first part of the 3D physics platformer. Now, one more thing. I know this is a very long part. But one more thing we're going to do is just show you that this is really 3D physics. We have true 3D physics. I'm going to make another ground object really quickly. 3D box. I'm going to just speed run this. You don't have to follow me right now. I'm just doing this for showcase purposes. We're going to add all the faces right now. And we have all of the faces set up. Add a behavior to it, 3D physics. And we're going to add the 3D physics behavior to the player, or to the ground. So let's make it static so it can't ever move, and hit apply. And now that we have this, we're going to stretch it out completely. And right now we're going to make a slope. So we have it on the side like this. So what we're going to do is rotate it, use the Z rotation. Well, actually, let's use the Y rotation. Actually, the X. I was wrong on all the rotations. Let's set these back to 0. And let's change the X rotation. Let's completely change the X rotation. And if I preview, let's look to our left. You see that we have this little slope. And if I jump on top of it, you see that I can actually move down the slope. It's not just some fake 3D. This is actually real 3D physics in GDevelop. So I want to showcase that. And that is how you create a 3D physics platformer, a prototype anyway of a 3D platformer. And this is just part 1. We're going to be animating the platformer as well and adding more features in this series. Now, of course, if you enjoyed the video, make sure to like, subscribe, comment down below what you would like to see next in the platformer series, or what videos you would like to see next in terms of 3D, because many more 3D games can now be made with 3D physics. The possibilities are now infinite. Once again, make sure to like, subscribe, and comment if you enjoyed the video, and I'll see you in the next part.